Hello student, in this lecture I will discuss about unit step response of a second order system. Basically I will derive the step response of a second order system. Okay, so we take the general form of second order transfer function, that is Ch by Rs is equivalent to omega n square divided by s square plus 2 zeta omega ns plus omega n square. Okay, so now we apply unit step input. So RT, we know the unit step signal RT equal to UT. Okay, so Laplace transform of this RT is Rs, and the Laplace transform of ut is equal to 1 by s. That means the Laplace transform of RT is Rs by 1, Rs equal to 1 by s. Okay, now we put this Rs in our second order transfer function. Okay, so after putting the value of Rs in our second order transfer function, then the output response Cs is look like this, which I have expressed in equation number 2.92. That's why Cs is equivalent to omega n square divided by s into s square plus 2 zeta omega ns plus omega n square. Okay, so see, in this case also we will obtain three types of responses depending on the value of zeta. So see, for first case we consider zeta less than 1 for step response. Okay, so for zeta less than 1, the roots of the characteristics equation are this S1 and S2. So S1 is equal to if zeta less than 1, then S1 is equivalent to minus zeta omega n plus j omega d, and S2 is equal to minus zeta omega n minus j omega d, where omega d is equivalent to omega n root under 1 minus zeta square. Okay, so here omega d is known as damped frequency of oscillation, and under this condition, output response Cs is equivalent to omega n square divided by s into s minus s1 into s minus s2. Okay, now here we put the value of S1 and S2. In place of S1 and S2, we put the value of S1 and S2. So S1 is our minus zeta omega n plus j omega d, and S2 is minus zeta omega n minus j omega d. Okay, now we do partial fraction. We will do partial fraction for obtaining the value of A, B and B star. Okay, so for finding the value of A, B and B star, we will do partial fraction. So after getting the value of A, B and B star, we put this value A, B and B star in equation number 2.93. Okay, so after putting the value of A, B and B star in equation number 2.93, then the equation will be this. Cs equal to, equation will be, after putting the value of A, B and B star, the equation will be this. Okay, so our output equation is Cs equal to 1 by s plus minus 0.5 plus j into 0.5 into zeta divided by root under 1 minus zeta square, this whole divided by s minus s1. Okay, plus minus 0.5 minus j into 0.5 into zeta divided by root under 1 minus zeta square, and this whole divided by s minus s2. Okay, now for finding the time response of output, we calculate CT. So how we will get CT? If we taking the inverse Laplace transform of this Cs, then we will get CT. Okay, so after taking inverse Laplace transform of Cs, we getting CT. So CT is equivalent to this. Okay, so here I will derive the CT. So after simulation after simplifying this equation we get Ct equal to this. Okay, Ct equal to 1 minus e to the power minus zeta omega t divided by root under 1 minus zeta square this into sin omega dt plus 5. Okay, where omega d is, I have already told omega d is equal to omega n root under 1 minus zeta square, and phi is equivalent to tan inverse root under 1 minus zeta square divided by zeta. Okay, so this is the output step response of second order system if we consider zeta less than 1. Okay, now come to the second case. Okay, for second case we consider zeta equal to 1. So if we consider zeta equal to 1, then the system is called critically damped system. Okay, so see, if zeta equal to 1, then the output equation, that means Cs equal to omega n square divided by s plus omega n whole square. I have already told this. Okay, I have already derived how this come in impulse response of second order system. Okay, so why this is s plus omega n whole square? Because if zeta equal to 1, then s1 and s2, that means the two roots are real and equal, that's why s plus omega n square. Okay, so if zeta equal to 1, then our equation, that means this equation, Cs equal to omega n square divided by s into s square plus 2 zeta omega n plus omega n square. So in this equation, if we put zeta equal to 1, then the equation will be this. Okay, now see, again here we do partial fraction. Okay, so after partial fraction, after doing the partial fraction, we get the value of a, b and c. So putting this value a, b, c in our equation, in this equation, putting the value of a, b, c, we put the value of a, b, c in our equation number 2.95. So after putting the value of ABC in our equation number 2.95, then the equation will be this. Okay, now again here we are doing inverse Laplace transform for getting the time response of output. Okay, so after taking inverse Laplace transform, Ct equal to 1 minus e to the power minus zeta omega n t minus omega n into t into e to the power minus zeta omega n t. Okay, so now after taking the term e to the power minus zeta omega n t common, then the equation Ct will be 1 minus 1 plus omega n t, and this is this into e to the power minus zeta omega n t for t greater or equal to 0. So see, in critically damped system, so where critically damped system means in this case we take zeta equal to 1. So if zeta equal to 1, then the inverse Laplace then the output response of second order system when input is step, then the output response Ct equal to 1 minus 1 plus omega n t, and this into e to the power minus zeta omega n t. Okay, now come to the third case. In third case, here we take zeta greater than 1. So if zeta greater than 1, then the system is called an overdamped system. Okay, so see, in the case of the overdamped system, the roots of the characteristics equation are real and non-repeated. That is, the roots are this. Okay, s1 equal to first root S1 equal to minus zeta omega n plus omega n root under zeta square minus 1, and S2 equal to minus zeta omega n minus omega n root under zeta square minus 1. Okay, so here again we will do partial fraction. Okay, so so after partial fraction we get the value of a, b and c. Okay, we will get the value of a, b and c. So put the value of a, b, c in this equation 2.97. Okay, so after putting the value of a, b, c in equation 2.97, then the equation will be so see here I have missed the term CS. Okay, so now you people put the value of ABC in this equation 2.97 equation. Okay, so after putting the value of ABC in this 2.97 equation, 2.97 equation, again we are taking inverse Laplace transform of that equation. So after inverse Laplace transform of this equation, we get the value of output in time domain is equivalent to 1 minus e to the power minus zeta omega n t divided by 2 into root under zeta square minus 1, and this whole into this term. Okay, so this is the output response of second order system when input is step, and in this case we consider the value of zeta is greater than 1. Okay, so here see here in this lecture I have derived the 3 output equation, output response of second order system. Okay, for zeta equal to 1, for zeta less than 1, and zeta greater than 1. Okay, thank you.